Ja, då tänkte jag lämna över till Reza från Chalmers som ska prata om hur man tar någons spill och gör det till en resurs. Och det är något som naturen har sysslat med i många miljoner år. Men här ska vi titta på hur man kan bygga broar av isolatorer som annars hade blivit avfall. Varsågod Reza.
Thank you so much, Ellen. I'm going to talk about our Recina project today. In this presentation, I'll briefly talk about Recina project, as I said, and the progress that we have made so far, and our plans for the rest of 2021. Recina project is about reusing end-of-life fiber reinforced polymer, as we know them as FRP materials in construction, and our goal is to promote sustainability in the infrastructure sector by reusing and repurposing durable and lightweight decommissioned FRP materials considered as waste otherwise. Chalmers and Reza have had a long history of a strategic collaboration in the field of FRP in construction and bringing this material into infrastructure sector in Sweden. We have run several projects together with our industrial partners in this area. For example, in Falcon project, we built the very first whole glass fiber glass FRP pedestrian bridge in Malmö since 2019. We have identified a problematic area, which is the FRP waste management in construction and other infrastructure sectors, and have been developing ideas about using end-of-life FRP materials instead of virgin FRP to help moving from linear to circular economy. One of the areas that has been heavily promoted for sustainable built environment, as you guys know, has been the wind energy. Wind turbines have a service life of around 20 to 25 years, after which they should be decommissioned. Over 90% of a wind turbine structure, of course, if you exclude the concrete foundation, can be recycled, except for the thermoset glass fiber reinforced polymer blades. For which, unfortunately, we don't have an environmentally friendly disposal solution today. There exist about 2 million tons of GFRP blades across the world to be decommissioned by 2030. So that is the size of the problem, and there will be many of them in Sweden. Today, most of these blades are actually sent to landfills or burned for energy recovery, both solutions posing environmental issues and hazards. Our research in this specific area is trying to find a solution to turn FRP waste from wind farms and other sources into a resource for building new structures such as pedestrian bridges. Our work includes identification of the needs to make this whole process happening, and also structural engineering aspects related to bridges and other objects to be built out of this waste material. Now, our vision by doing so is just to give a second life to these waste materials and buy time for science to come up with a sustainable solution to recycle these materials in the future. The reuse of blades has been the subject of several projects. For example, different research groups in the United States are looking into reusing the blades for housing, and some architects in Netherlands use blades in playgrounds and to build, other urban objects. But there is a consensus among researchers and activists in this field that for the time being, repurposing and reusing is the most environmentally solution that we have on the table. And that actually is the backbone of Recina project. This is a concept that we have developed for short to medium span pedestrian bridges in another project, which is running parallel to Recina, called Blade to Bridge. And that is being run in collaboration with the SPECO, and we intend to use at least 90% waste FRP materials in this concept. So specifically in Recina project, we are looking into possibilities to build decking elements for such bridges. Recina again specifically addresses the use of production waste of GFRP electrical insulator pipes from ABB Hitachi to build the required deck elements. And this is what the pipes or insulators look like. They are produced using filament winding and have a diameter of 200 millimeters up to 1 meter, so they could be that large. Some of these pipes do not pass the requirements for electrical insulation, and despite their excellent mechanical properties, they are rejected and they are actually sent to landfills. There is a silicon protective layer if you just take a look at the figure in the left on the final product, but the waste which is rejected doesn't have the silicon layer. It's quite similar to what you see on the top right corner, and this is the material that we are going to use. So we are 7 partners in Recina project, including ABB Hitachi, Rise, Chalmers, Podcom, Composite Design, Marstrom, and Event Hotel, covering almost the whole chain from waste producers to manufacturers. We have had a lot of brainstorming about how to use these pipes to make flat panels for the purpose of this project. And we came up with some concepts as visualized in this slide. And we compared these concepts based on a number of criteria, taking into account the ease of production, price, possible environmental impacts, and some other factors. We have also used finite element analysis to investigate the behavior of such panels and study the effect of different parameters such as diameter of the pipes to be used in order to maximize the utilization of the material. And in general, we have observed a satisfactory behavior with respect to strength, stiffness, and vibration of such panels. So the next step for us was to prototype the concept. In order to build our sandwich elements, we decided to use waste panels from Podcom. And Podcom produces prefabricated bathroom modules that are located up in north, close to PTO. And Podcom, to install the door actually into these modules, Podcom cuts out a part of the walls, as you see in this figure. And these cutouts are in the order of 2 meter by 1 meter in size. Of course, they don't have any other solution or usage for these cutouts, so they get rid of them. So we decided to slice the pipes and sandwich them between the panels from Podcom and simply bond them together as illustrated in this figure. So these panels, this is an example of a sandwich panel that we have built as demonstrated by these 3 guys standing on one of the demonstrators that we built. So we have actually done some experimental testing with satisfactory results. So one of these panels that we tested, even though the design load was around 1 ton, it managed actually 5 tons of load. Getting to what is happening next is that in the next step, of course, 2 activities are to be concluded in the project before the end of the year. We will build a small demonstrator bridge around 6 meters long for Mölndals Golf Club. We have already agreed on the details of this bridge, and the waste material from ABB Hitachi and Podcom have been actually sent to Composite Design, and hopefully during summer we will build this bridge, and we will perform an LCA analysis to really gauge the efficacy and sustainability of this solution. And then for the rest of the project, we will continue actually conceptualizing other applications in the project. 2 of the most promising ones are using these panels as sound barrier walls and for walkways, plus the fact that we have other ideas for using this for roofing panels, urban objects again, lightweight balconies, and so forth. That was my last slide, Elin, and I'll be happy to answer questions if there are any.